Okay, so question number 4 is how do you distinguish polarity of molecules using the periodic table of elements? So first I'll just say at the top that a periodic table can show the electronegativity values of all of the elements. So let me look up what this will look like. So some periodic tables will contain a lot of information. So here's a periodic table that only includes electronegativity values of the elements. So now we can have different types of molecules. And depending on their electronegativity values, this can tell us about the polarity of the molecule. So for example, we can have a nonpolar covalent bond So this is when two atoms have equal or similar electronegative values or electronegativity values. So typically, the difference in electronegativity is equal to around 0 to 0.4. And some examples of nonpolar covalent bonds would be diatomic elements, such as a nitrogen-nitrogen. Obviously, they have the same electronegativity value, so their difference in electronegativity would just be 0. And another example would be the carbon-hydrogen bond. So for example, if we were to find out the difference in electronegativity between carbon and hydrogen, we would look at this table and see that carbon has an electronegativity value of 2.5 and hydrogen's is 2.1. So their difference is only 0.4, making the bond nonpolar. Okay, so we can also have a polar covalent bond. This is when two atoms have dissimilar electronegativity values. And typically their difference in electronegativity ranges. So it's greater than or equal to 0.5, but less than 1.69. And some examples of polar covalent bonds would be like the hydrogen-oxygen bond. So let's calculate its difference in electronegativity. Oxygen has an electronegativity value of 3.5 and hydrogen's is 2.1. So the difference between the two is 1.4, which lies within this range, making the hydrogen-oxygen bond polar. Another example would be like the phosphorus and fluorine bond, and so on. So when we have covalent bonds, whether it's nonpolar or polar, they both involve the sharing of electrons between nonmetals. And the reason I wanted to say that is because we can also have an ionic bond. So ionic bonds are between a metal and a nonmetal. So even if you were to calculate the difference in electronegativity between a polar covalent bond and it was greater than 1.69, if it doesn't include a metal in it, it is still considered polar, because ionic bonds are between a metal and a nonmetal. So typically, their electronegativity differences are much higher, so they're greater than 1.7. And an example would be like potassium and fluoride. If we were to calculate their difference in electronegativity, fluorine has an electronegativity of 4, and potassium's is only 0.8. So the difference between the two is much greater. It's 3.2. Okay, so this is how you can tell if you have nonpolar or polar bonds or even an ionic bond. But in order to see if we have a polar or nonpolar molecule, when the net dipole moment of a molecule is 0, then we have a nonpolar molecule. And typically it's symmetrical, so the dipole moments will cancel each other out. And when there's a dipole moment, a non-zero dipole moment, then we have a polar molecule. Okay, so the junior tutor said that in order to determine what a polar molecule is, we first need to distinguish the difference between polar and nonpolar molecules. Okay, so polar molecules occur when two atoms do not share electrons equally in a covalent bond. So these are polar covalent bonds, and with part of the molecule carrying a slight positive charge and the other part carrying a slightly negative charge, a dipole is formed. This is possible because there's a difference between electronegativity values of each atom. A huge difference forms an ionic bond, and if there's a lesser difference, a polar covalent bond is formed. For example, if the electronegativity difference between two atoms is between 0.5 and 2, the atoms form a polar covalent bond. So you can see here they use the range of 0.5 to 2, but other sources will say it's around 1.69. But again, if it's greater than 1.69 but only contains two nonmetals, then you know that it's polar covalent. On the other hand, if the electronegativity difference exceeds 2, the atoms form an ionic bond. Extremely polar molecules include ionic compounds, and they have some examples. Okay, so they go on to talk about an example with hydrogen and chlorine, and how the unequal sharing of the bonding pair results in a partial negative and partial positive charge. Nonpolar molecules are formed when atoms sharing an polar bond arrange such that the electric charges cancel out. In a nonpolar covalent bond, the electrons are evenly distributed. Nonpolar molecules are predicted when atoms have the same electronegativity, and it's less than 0.5. Okay. So this solution is correct.